All right. So, I kind of hinted about the fact we're going to talk about this sampling techniques, and that's what that very first problem was about on the sheet we just did. So the gold standard for any sampling technique is for it to be what's called random. And we already discussed what makes something random, a truly random sample. Custodian, remind me what makes something a truly random sample.
Everybody has an equal chance to be included within the sample.
Yes, every element in the population has a chance to get into the sample. To be really honest, it should be has an equal chance to be in the sample. Okay, that is the gold standard. Now, if I just randomly sample people at Grossmont, would it be impossible for me to pick like 20 people who are all older than 50? Is that impossible? Of course it's not impossible, right? So I do everything I can to make sure everybody has an equal chance. That does not mean my sample is going to be great, which is why one of the main things in science is that if my group sees something, I won't accept it until other groups have replicated that same thing. Because maybe I just happen to do some stuff and I happen to pick a weird sample. Does that make sense? This is why repeatability is huge in the sciences. Okay. So this is the gold standard. Now I'm going to talk about some more specific ways to do things that have certain methodologies to them. So for example, there's something called systematic sampling. By the way, this is sampling methods, if you want to give this a little title. Systematic sampling. Whenever I say that, I say systematic, automatic. Does anyone have any clue what systematic sampling might be?
Is it like intentional selection of people?
No, that would suck, right? But you're right. You don't know at the moment if this is good or bad. It's just a sample method. So there's a system to it, but to be more precise, it's every nth. So for example, if I walk outside and take the temperature every 10 minutes, if I take every fifth person that walks by me, if I take every fifth, it doesn't have to be 5, by the way, if I take every 7th test that I grade of students, right? And I use that as my sample. That's all systematic. So systematic can be broken down to every nth something. You guys ever seen nth before? Okay. So if I walk every 50 feet, I collect grass for a sample to see how they're being affected by chemicals. That would be systematic because it's every 10 feet. Yeah, sorry.
So every third step, does that fall into that category?
Sure. If I look every third step, how many cracks are in that step or whatever? Yeah. Every nth. If you could say every nth thing, systematic. Why would, go ahead, sorry.
Does it have to be more than, can it be more than 2, like every group?
Yeah, you can do every 1,000th person.
But after the first 1,000th, second 1,000th, can that still be the same system? Can that be a system, or does it need to be 3 or more of the nth?
Oh, so it's got to be every set. It's got to be a set number, right? So every 10th thing, every.
And it doesn't matter if it's more than 1,
Doesn't
more
matter.
than 2, or
No.
just every.
Now every. You can do every other, sure, right? And the really key thing before I forget is, we already talked about this, to be honest. The first thing you pick is picked randomly, right? So if I wanted to pick every third person in here, this is like I said the other day, I could randomly pick somebody to start at, and then every third person after that. Is that an example of random sampling?
Yes.
Yes. Because there's nobody you could show me did not have a chance to get into the sample. Yes? So if I randomly pick the first person, you, and then 1, 2, 3, I take you and I take the third, and then I count 3, everybody had a chance. Don't go, well, you didn't pick Susie. No, did Susie have a chance? Yes, everybody had a chance. I love it. Okay. The next two kind of go together. I'm going to give myself some more. They're interesting. One's called stratified, and the other's called cluster. Yes?
Stratified would have layers, like strata in the earth.
Okay, sort of. I like that. Strata is a very geological term, talking about layers of sediment and rock and so forth. It's sort of like that. Okay. Yes?
Is it more spread out like demographics kind of thing?
Yeah. Okay, so stratified. Here's why I want to put both of these down. They both have the same first step. First step for both of them is break your population into groups. So for example, if my population was a high school, I could break them into freshmen, sophomores, juniors, seniors. Why do you think I'd want to do that? If I just randomly pick 100 people, students out of high school, is it possible that no freshmen are picked?
Yes.
So if I want every group to buy into my results, don't I want to guarantee I get not necessarily equal, but I want representation from every group?
Yeah.
There's something called proportional stratified, which is you pick the same percentage of each group, but that's an extra layer we don't have to worry about. Just to let you know. So both stratified and cluster break your population up into groups. So again, it could be zip codes. And then I pick a certain number of people from each zip code and so forth. What stratified does is what I just said. Stratified takes some people from each group, and that's what goes into my sample. So the key word there is the key phrase is some from all. So if I took 2 books from every library to be in a sample, okay, that's stratified. Yes? Okay, I like it. If I took 5 students from every classroom, that's stratified. Okay, I like it. Cluster, what cluster does is it randomly picks groups and then takes everybody from those groups are in my sample. So cluster is all from some. So what's nice, again, stratified is some from all. Can't do it for cluster though, sorry. Cluster is all from some. How are you guys doing? So for example, stratified here would be, I take 1 student from every row. I randomly pick 1 student from every row. Is that random sampling?
No.
Who did not have a chance? Point to the person in here that did not have a chance to get into the sample. Wherever that no came from, sorry. Do you understand what I mean? So to be random, whatever method I'm using must allow for everybody in the population to get into the sample. Is that cool? So if I take 1 person from each row randomly, is there anyone that had no chance to get into the sample?
No.
You can say me, but let's say my population of students in the room,
Yeah.
right? So that's random. What about cluster? Cluster would go, I randomly pick 4 rows, and I take everybody from those rows.
No.
Is that random?
Cluster's not random because a large portion of the population never had the chance
No,
to be a part
point
of
to
it.
the people who didn't have a chance. So I randomly pick rows. I'll pick this row, and this row, and this row.
There's less chance of them.
Who did not have a chance? Now again, didn't I just...
Okay, yeah. All right.
I could randomly pick any freaking rows in here, yes? If I again, I didn't really just randomly, but I like 1, 2, 3, 4 row, and I put it in a hat, and I pick it out, and then I take everybody from that row. Every single person in here had a chance. You guys understand? You can't look at it once the sample's set up and go, well, I didn't do it. No. Did they have a chance to get in? Yes.
Can you make clustered something like non-random, where you say like every second row I'm picking that row, like every other row I'm taking the row?
That's still got a cluster. It's sort of, and again, you kind of hit on something interesting is you can have combinations of this, but let's not go there. Right? But yeah, that would sort of be a combination of systematic and cluster. That would be completely fine as long as the first row is randomly selected. Yeah. There was an example one semester it was actually a January about 12 years ago, I was teaching this course in 3 weeks. And a student said, Jeff, cluster is bullshit. And I was like, that's interesting. It's very interesting. And they were somebody who had fought in the Iraq War. And there was a company who traveled to Iraq, and they were going to take a cluster sample of neighborhoods to see what the conditions were, just to get a general sense of how well. This is after the capture, and after a while, they want to see how things were kind of coming back. And what the company did was they said, well, let's not include these neighborhoods because they're dangerous. I don't want to go there. So right off the bat, is that random? If I go, these, no, let's not go there. Why is that not random? Because they didn't have a chance. So it was really neat because he had decided cluster sucked, which was different because I normally have students that don't have a clue what cluster is, and this guy's like, I know what it is and it sucks. So we kind of had a discussion about why that application sucked, right? You guys kind of with me? Okay. I like it. So any of these methods here, they can be this. And we want them to be this. So what kind of problem would I give you that was actually just this? Names in a hat. That's not systematic, that's not stratified, that's not cluster, correct? That is just random. Random number generator. And assign numbers to everybody, that's random. You guys semi with me? Okay. There is a fifth method that I'm going to put over here. And it's called convenience. And I think I already talked about this a little bit. So you guys were a convenient sample that I was trying to use to represent, bless you, all Gross 1 students. You are convenient, correct? I'm not having to do any work. I'm just like, you guys answer this question or you failed. So it's convenient for me to get it. I'm not even trying to make it a random sample. Why are you guys a bad sample to represent Gross 1? We already talked about that, remember? Because you're all here, you're all taking stats, you're all here at this time, you're taking a summer course. So not everybody in the population has an equal chance, right? So convenience just means you did nothing to try to get close to this standard. It truly is just exactly what it sounds like. I just talk to people as they walk by the door. What? How do you even know they're Gross 1 students? What? Does that make sense? That's over there. That's bad. Okay. I like it. Maybe. If you completely, accurately utilize one of these methods, does that mean your sample is representative of the population? If you do everything perfectly right, does it mean the sample you end up with is representative of the population? Nope. Not necessarily. Because again, the whole point is random. Could you randomly, like I said earlier, could you randomly pick Gross 1 students and they all happen to be over 50? So when you take their average age, will that represent? No, but that's the point of statistics is you don't know. That's why, again, we want to do it over and over and over again. We want to do several people doing their own samples just to make sure that we're seeing something that's true. Yes, sorry.
So all of these are just on the basis of a random sample?
All of them can be this. You're doing everything you can to ensure this. On a test or a quiz, if I don't say every 5th minute, if I don't say I broke it up into groups and I took whatever, if I just said, I pick, I randomly pick people, then that's random. But if you see me saying I say every 10th or I break up other group, then that's got to be one of these guys. Yeah, and of course the convenience one will be pretty obvious, right? I just take the tests that are closest to me without having to stand up. It's such a good word for it. Whatever's convenient instead of trying to make it random. Okay. You guys with me? So there's this idea, let me say this word, variability. What does that mean in relation to statistics and taking samples?
The spread of each comment in the sample, I guess?
Yeah, so if you went and took a sample of 50 Gross 1 students, and I go and take my own sample of 50 Gross 1 students, will our average ages of our samples be the same necessarily?
Not necessarily.
In fact, I'd put a lot of money, and again, I'm a teacher, we don't make a lot. I'd put a lot of money on them being different. because of sample variability. You guys with me? If I took a sample of 2 people, how much are you going to trust the average I get from that? Not freaking all. So of course a bigger sample sort of helps tamper that down, but it still doesn't guarantee it. Okay. I'll stop. So coming back to this first question on the practice thing we did. You guys remember this problem? So which sampling technique? Don't say anything. Let everybody kind of look back at it. Do it. Okay, all right. So this question here, what do you think? Yeah, obviously they broke the population into groups, correct? Heavy wine drinker, light wine drinker, and doesn't drink wine. And then they took some from each group, correct?
Yeah.
And it makes sense. Why would they want to do that in this kind of problem? Because they want to guarantee that they get various levels of wine drinking or absence of wine drinking. Otherwise, they can't really calculate percentages and so forth accurately. Could they have picked a sample if they just did from all Ecuadorians and only got people that don't drink wine?
Yes.
Totally. Yeah. Yes.
I was wondering why they wouldn't have made the groups equal.
Oh, good point. Sometimes it's just the way things kind of shake out. Sometimes they do it on purpose. Sometimes it's, like I said earlier, proportional. So if this was proportional, that would mean that a larger percentage of Ecuadorians are heavy wine drinkers, a slightly smaller percentage don't drink wine, and a smaller percentage only drink a little bit of wine. So I could pick stratified, like I said earlier, I could do stratified selection proportional to how big each group is. So in a high school, if I had 1,000 freshmen and 200 seniors, and I take 10 from each group, that's not truly, right? Does that make sense? It's not truly representative. I could take 10% from each group. That would be more representative. Okay, I like it. Okay. So, let me say one thing about this that will really excite you guys. I'm not going to talk about section 1.4 today. It's sort of part of your homework to read it. And then I've got 3 questions from section 1.4. One of them deals with terminology from section 1.4. You can totally ask questions about it, correct? Once you've read it and you try the homework, you can totally ask questions about it. I'm just going to kind of, it's my little teacher thing to do. You guys read it. Okay. So what we're going to do now is finally get into some data, right? We're going to crunch some freaking data, which is what everybody thought you're going to be doing immediately. So we're going to talk about the most basic level of statistical analysis, which is descriptive statistics, which is just creating graphs and other visual references for what you see in your sample. So, let's see. Let's do this. This might be interesting. Would anyone feel weird? Would everyone feel okay telling me your age? Maybe not. Okay. Would you not feel comfortable?
No, I'll feel
Okay. Okay. So what's up?
20, turning 21.
Okay, I'll start with you.
Months.
So you're 20 at the moment, right?
Yep.
Okay.
21 2
So you're
months.
20 at the moment. Okay. 19.
18?
18. 21.
19.
19. For a minute, I thought you said 92. I'm like, damn. 19.
29.
29.
23.
23.
30.
30.
19.
19.
23.
23.
27.
27.
17.
17. Lloyd? How old are you? You don't have to tell me yet.
35.
Six,
25.
25? Robert?
26.
26.
19.
19?
21.
21?
20.
20? 20?
39.
39?
19.
19. Okay, I'll put myself up here. Yeah. All right. So, the very first, most basic level of just representing data really quickly. This sucks up here. Would you agree? If you just looked at this, could you tell much of anything immediately? Not really. I mean, you could tell that most people are under 40 and all this kind of stuff, right? But you can't really tell how things are distributed or anything. So one of the most basic things we could do is create what's called a stem and leaf plot. I think the book just calls it a stem plot because it's boring.
Most everyone's 19.
There you go. Here, you speak for a bit. Oh, shoot, sorry.
You killed it, the monster's dead.
It won't bother our village anymore.
Was 19.
So here's stem and leaf. How do I say this? The ages. There are some people who are in the teens. Keep going. There's also some people who are in their 20s. There's some people who are in their 30s. Is everybody 40? No. Then there's me. I might be an outlier. So here's the beautiful thing about the name of this. This isn't something I made up, by the way. This is the name. The stems, the stems are the digit that's repeated. So in this case, it's the 1, 2, 3, the beginning, right? So I have some in their teens, 20s, 30s. Nobody's in their 40s, but I got to represent it. 50. So I want to represent everything that captures all the data. There's also a nice way to kind of sort your data relatively quickly. What's the lowest age?
17.
17. And then 18, right? Do I have another 18? Let me cross these out as I go. There's one 18, right? Okay, I'm going to rely on you guys.
Yeah.
And then I got a bunch of 19s. Let's see. 1, 2, 3, 4, 5, 6. I think there's 6. 1, 2, 3, 4, 5, 6. Okay. All right. And then we got some 20s. How many 20s we got?
3.
1, 2, 3.
Professor,
Yes, sir.
would you please, I wasn't paying attention to that part. Would you go over that again? 7, 8, 9, under 1? What's that?
So this means 17, 18, 19.
Okay.
It's a quick way to represent your data, and it's just a smart thing. It's like, why write the 1 many times? Let me write it once, and then just put all. So these are the stems, and then you got your leaves coming. It's like a stem, and you got your leaves coming off here. All right. Yes, sorry.
Would this be section 1.2?
This is actually chapter 2.
Oh,
Yeah, we're done with. Well, we're not done. 1.3 I'm going to come back to in a minute, but it leads right into section 2.2, which is kind of weird, but. Okay. And again, sometimes I don't really know where things are in the book. I'm sorry. So I was telling somebody else that if you're like, wait, where are we? Just give me a minute. I'll figure out where we are. I just know shit. I don't know where it is. So 20, that's on my 20s. 21, I got 1, 2, thank you. Welcome, my sheet. And then I got
2 23s.
23, 23.
No, 24s, 125, 126, and 127.
25, thank you. 26,
27 and a 29.
27, 20. So I got 5, 6, 7, 9. All right. Is everybody with what is happening? Am I with what is happening? I think so. Okay.
130, 139, and then 150.
Yeah. So 30, 39, 50. Okay. If you make your head go like this, whoop, you can see what the most is. Yes. You guys have seen pictures like this before, of course. Yes? If you make your head go like this, doesn't that basically become that?
Yeah, like a
Is there an empty class?
Yes.
Yes. These are, we can call these classes, and the 40s is empty. So it would be represented by, like, little, missing tooth there. So we're going to do these next. But this is like a really rudimentary example of one of these if you just tilted your head. This is not complete until I use a key. You have to, so you're not going to show somebody the data. You're going to show somebody this, which is the data, but you have to tell them how to read it. So what does 1 line 7 mean?
17.
There you go. Cool. That's it. That's stem and leaf. Yeah, totally. It's like, yes, Jeff, can everything be like that? No, I'm sorry. No, you can't. Is everybody cool with that? Because I'm going to make one little tweak, and I don't really necessarily want you to like recopy everything. Just watch. Don't even copy. Just consider this. If my data would have been, this doesn't make sense for the question, but maybe it does. Let's say that instead of 2, you're 2.0, 1.9, 1.8, 2.1, 1.9, right? If all the data was like that, this would look exactly the same. I would just do this.
The line would just represent the
Well, I do it better. There we go, Jeff. Right? You guys with me? Okay. Or if it would have been 200, 190, 180, 210, we're all pretty old. I don't know what the hell we're doing here, but this could still look exactly the same. And then my key would be 17 equals 170, because then somebody could just read it off then. Please, dear God, I one time had somebody do the key and they did every single element. It's not the point. That kind of goes against the point, right? Okay. All right, nice. Accept that. It's so beautiful. Stem and leaf, relatively easy. If you don't put the key, you lose points. The next level of thing we're going to look at, there's a few things in the book I'm not going to even worry about. There's something called an ogive, and there's some other weird shit. So I want to stem and leaf. Do you remember this? No, this book doesn't do dot plots. We're going to get right into what's called a histogram. And this relates to section 1.3, and it relates to section 2.2. So I'll try to make it really clear what part 1.3 is going to want you to do, and then there's extra stuff that 2.2 wants you to do. It's a little twofer for me. Has everybody got what they want from that? All right. Well, actually, yeah, we'll use the same data, Jeff. Dear God. I kind of suck though, because I kind of pull us really weird. Oh well. I will still do it. Okay, let's see. This should look really nice and weird. So to construct a histogram, what does a histogram look like? Let's do this. Yeah, let's do this. Before I get into the construction of histograms, let me let you guys try out some stem and leaf. I have a histogram, but it's already been constructed. Don't worry about the back of this sheet yet. This time I'm going to let you guys start off by yourselves, and then I'll have you compare answers with other people near you, and then we'll talk about it. So number 1 should be very straightforward. Number 2, I will tell you, is a little weird. If you don't quite get it, it's okay. Number 3, I just want to see what you think. I guess I can pause this. Which is a little on the nose, but which is kind of nice. We want things on the nose. All right, let's take a look here. Holy crap, you zoomed in, Jeff. All right, cool. So this first one, real quick, you guys will help me out. Hopefully everybody got this. What'd you guys get here? 1, 2, 3, 6, 12, 13, 16, and then 20. No 20s? Yeah, look at that. 3.
1, 2, 2, 3, 5, 7.
5, 7, 8. Is that cool? Okay. 4. 1, 5, 6. 1, 1, 5, 6. Okay. And then 5, 0, 2. Now that's a beautiful stem and leaf. Why would you lose points if this is where you stop?
You didn't make the key.
Man, so key, it doesn't matter. It doesn't, watch, I could do this. Key 3, 5 equals 35. It doesn't matter which one you pick. Somebody was asking me, do you have to pick the one with the 0? No, just any of them. You can even pick one that isn't even on there, right? You can say key 72 is 72 plus you. Because it gives me the idea I need to read it. Correct? I love it. The trick with number 2, and again, this is not going to happen that often. I just wanted to see what you guys thought about it. And again, I'm going to say this word resolution a few times. Increase the resolution. So instead of doing 4, 5, I'm going to do 4, 4, 5, 5. And the idea is instead of breaking up from 4-0 to 4-9 and then 5-0 to 5-9, we do 4-0 to 4-4, 4-5 to 4-9. Same thing for the 5s. Does that make sense?
No.
So again, if I just did 4, 5, right? If I just did 4, 5, what would I put here? All the things that are from 4-0 to 4-9, correct?
Well, where's the 4, 5 come from?
Go with me,
Okay.
right now. So this first row, I would put everything from 4-0 to 4-9, correct?
Okay.
Is that cool? I would put 0s and 1s and up to 9. That would mean 4-0 to 4-9, yes?
Okay.
And then here I would put 5-0 to 5-9.
Okay, thank you.
So all I'm saying is, why break it between 4 and 5? Why not break it in the middle of 4? Why not make this 4-0 to 4-4 and this 4-5 to 4-9?
It says make 4 rows.
Exactly. So how many rows will I have now? 4. Yeah. So again, this is not going to happen. In fact, it's not going to happen to you at all in the homework. It's not going to happen to you all ever more in this class. And some of you guys are like, well, why do I want to know about it? It's not going to be on the test. Because it's freaking the idea. But it's just another level of flexibility we have with STEM, just to give us more resolution. So you can imagine, what if I had a whole set of data where the lowest number was 10 and the highest number was 19? That would just be 1 with all the data. Right? So then maybe I want to break it up into 10 to 12 and 13 to 15 and so forth. Yes? Okay. If that will work, I think. So then I'm not going to do this. Hopefully you understand.
That way we don't see it so black and white and there's more depth.
I can, yeah. So if I did 4 or 5, and I think a few of you guys did, you just get this long ass row of these numbers that doesn't really show you how things are distributed. And what's the key thing about this data that tells me I might want to break it out more? Well, it goes from 4.0 to 5.9. Is that really widespread? No, it's not widespread. 4 to 5. So then I want to break it up a little more so I can see how things are really distributed. So GPAs, well, it's not a great example, but something that's not really spread out enough on its own, I want to break it up more so I can kind of see where things fall. So in this case, what's the first 4? It would be, so it'd be 0, 2, 2? 2 zeros, okay. Bam. And a 5? No, 5 would go down here. Yeah. Blah, 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 blah. Okay. I'm going to move past that because it's not that big of a deal. I just wanted to show you a little bit more you can do with STEM and Leaf. Now, on number 3, we didn't talk about classes. I did say the word class earlier, and it's basically the same idea, same way I used it earlier. How many customers did they survey? How many are in this column here? 11. So the frequency is how frequently somebody showed up between these number of weeks. So there's 11 here, so then you can just add them all up and you get how many? 20. Kick ass. Go over there. How many classes? Let me ask this first. How many empty classes are there?
2.
Good. So now how many classes are there?
6.
Totally. Because I'll get somebody to tell me there's 4 classes, but there's 2 empty. So there's 6 total classes. Is that cool? What is the class width? Well, just how wide is any of the classes? They're all how wide? 20. Does everybody see that? Okay.
No.
Uh-oh. Do you see 6 classes? Do you see 2 empty classes?
Yes.
Yes. These 2 right here, yes? These 2 are empty. So there's 1, 2, 3, 4, 5, 6 classes. Pick one of them. How wide is it? Pick any one of them. How wide is it? They're 20 wide, right? So cool. 20, 20, 20. Okay. Yes?
So I wrote 6 by 20. Is that?
Oh, that's neat. So yeah. Sure, yeah. It's not a general thing we do, but I
Yeah.
understand. Okay.
And for the people, this is how many customers? I got 31 because I added all of these. That's wrong. How did you do that?
So how many in the first class? 11 plus 6 is 17, plus 2 is 19, plus 1. By the way, guys, I don't feel bad if you're, after I explain, you're like, oh my god, that was that easy. This is all new shit. We don't do this all the time. So it's going to be at first time, it's going to be a little weird, but then it kind of clicks. It's all good. Part C has a little more work to do. What does at least mean? Well, okay, I see. Yes, I'm with you. So what I have in my mind is, if I see at least, I think you have to be at least this tall to ride the ride. So that tall or more. At most is like you can be at most 12 and you eat off the kids menu at Denny's or something. I don't know if that's true, but you with me? So up to. So at most means up to, and at least means up from. So at least 40 means these people. And how many people is that? At least 40 is these people. And that's how many people? 3 people. Out of how many total people? 20. And that's how you make a percentage. If I multiply by 5, I get it out of 100, so I get 15%. Is that cool? Or you just do 3 divided by 20 in your calculator and then move the decimal over. Is that okay? Yes?
Wouldn't it be 9 out of 20? Because the second class there goes up to 40 weeks. The second class?
No, it's at least 40 weeks. So,
Right.
yeah. So this would be up to, yeah, I know there's a little bit of a wiggle there, but just go.
Well,
I don't want to include all these people because
Oh,
are there
that
people
goes
in
up
here that
to-
has less than 40?
oh, it goes 20 to 40. Okay.
Up to 40, and I want at least
Okay.
40, yeah. Okay.
Great.
All right. Yes.
Sorry, what did you say?
Oh, sorry. How many people at least 40 weeks? Starting at 40, go up. How many people is that? 3.
Oh,
Yeah, cool. I like it.
Starting at 40, you go up to where?
Just up forever.
Oh.
So if I start at 40 and go up, how many people do I collect? 2 here, 1 more there. I love it. So at least means greater than or equal to. Okay, I like it. Okay. So I don't have that much time left. Damn it. So let me talk about, okay. Let me talk about the idea of this very quickly. So part A, we'll do that next time. I want to talk about part B and why the equation is what it is. So, let me say something very silly. Let's see. Sort of equally, okay. See in the back of the room, see the panels?
Yeah.
Everybody see those? Those are rectangles, correct? I always wanted to check to make sure.
I think so.
Okay. Thank you. So, you could determine, you could actually measure how wide each panel is, multiply it by how many panels are, and you can figure out how wide this wall is. Is that correct?
Yeah.
So, if we, let's think about that backwards. Let's say I have some person who's like, no, this is aesthetically, that's not good. I want to have, I want to use 12 rectangles, not just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so they want to use 12. 12 is their favorite number. You with me? How could we figure out how big each rectangle should be? If I know, let's say, if I know this is, I don't know, if I know it's 120 feet, and I want to use 12 rectangles. Yeah, so how wide should each rectangle be? 10. You guys semi with me? Okay, so watch this. And that last thing we did, that last problem, of course you guys didn't see any of that, sorry. These rectangles are 20 wide. Well, what's the highest data point that I could have in this problem? Ever see that? What's the highest data point that I could get?
120.
120. What's the lowest data point I can get?
0.
So how far do I have to cover? Like the length of that whole wall, correct? How far do I have to cover? 120. That's weird because I didn't really do that on purpose. But and then how many classes did they use? 6. And what's 120 divided by 6? 20. Holy shit. And that's why their width was 20. So what we're going to do is we're going to be the ones actually constructing the histogram. This was somebody else already freaking made it. So look at this problem. How do I figure out how long the wall is? How do I figure out how wide the data is? I got to take the highest data point minus the lowest. What's the highest data point? Can anybody see it?
79.
79? Minus what's the lowest?
61.
61? So that is equivalent to so many things in statistics and math in general. You can think of physically. That is how long the wall is. And then we want to use 5 classes.
18 divided by 5, 3.6, round up 4.
Yeah, and remember dividing by 5 is quick because you just double and then move the decimal back 1, or you just do it in the calculator. Anytime you get a decimal, you round it up. Oh, I'm sorry, I'm not showing you anything I'm doing. I'm sorry. I'm not used to using this thing. That's why the formula is how it is. Now, the last thing I'll do with you today, and then next time we'll finish this up. What's the smallest data point again? It's 61, right?
Yeah.
So I'm going to make a bunch of classes. For example, up here, what's the very first class? From what to what? 0 to 20. And how many things are in that first class? 11. Okay, so we're going to construct that first. Our first class starts at 61, correct?
Yes.
How wide are the classes again? We just figured that out.
4.
4. So where should my next class start? All right, is everybody cool with that, right? Can I put a 65 here also? Because then where would 65 go? It's got 2 places to go. Yeah, I like it. So then you just keep adding 5 down until you go slightly insane. Yeah. It's not a requirement to go insane, but it could happen. Oh, I went too far. Wait a minute. Did I do that right? Add 4. Why don't I add 5? I love it, Jeff. Yeah. I'm awesome. 61, 64. Now you add 4. 65 to 68. I was adding 5 for some reason. 69 to 72. See, I'm just adding 4 down. Does that make sense? I'm going to add 4, 73, and I'm going to add 4, 76. I'm going to add 4, 77, add 4, 80.
Wait, wouldn't it still be 69 if you're adding 4 and 5?
Yeah, so that's why I got 65, 69. Yeah.
Oh, yeah.
Is that cool?
Yes.
And then all you do is the frequency is just the number of data points that shows up in this class. So obviously, once I show you how to sort the data, this kind of work is going to be stupid quick. But real quick, let's just see. How many 61s? I got 1, 2, right?
I was going to say, I got 2, 13, 16, 3, and 0 for each.
Yeah, because do you have any 62s?
No.
63s?
It jumps from 61 to 66.
All right, let me catch up. And then 64s, there's none of those. So I have 2 things that are between 61 and 64. Is that cool? And then you just keep going like Robert did. You just keep going. And if I can just sort the damn data, that'll be quick. So next time we'll put this data in the calculator. I'll show you how to sort it. I'll bring my cooler calculators with me in case you don't have one yet. And then we'll finish this out. And we'll end up with a picture that's, a bunch of rectangles. And we'll talk about what it means. Okay. All right. And just a real quick reminder, I think most of you guys have filled out the survey, but if you haven't filled it out yet, just get in Canvas, fill out those 2 surveys for me. That would be much appreciated. Let me know if you have any questions about anything. Otherwise, I'll see you tomorrow.
So, for like mine, I did 60.